afternoon to everyone. This is Dr. B. Polaiah, working as a professor in the Department of IT, Institute of Aeronautical Engineering, Hyderabad. I'm very glad to inform you about our today video lecture. That is what we are discussing about so far, the image processing, which we are going to repeat in terms of definitions and terminology on image processing topics. So let me go ahead one by another towards to understand the meaning of definitions about image processing. Let me to take one of the topic which we called here is line detection. So what does it mean line detection in image processing? So that we simply define in terms of detecting a line in a certain directions required detecting adjacent points in the image in the given direction. This can be done using filters that yields significant response at points aligned in the given direction. For example, the following filters. What are we had the following filters which we define in terms of matrices also. So that is the highlights, the highlight lines in the vertical and horizontal with the direction which we can mention 45 degrees in positive direction and negative direction of 45 degrees respectively. If you are positively restrict in that direction, how we may represent in terms of your image data, which is represent in terms of minus values and positive values. So we can observe in this table which we are going to be observed either positive values and what we call the negative values. So what do you mean these negative values and positive values are, which we are going to be keep in terms of filtration process in the image using an appropriate filter which are we defined either in the form of vertical and horizontal. Either in the form of vertical or horizontal. So that we'll apply appropriate threshold value which we are defined in terms of maximum value based on the knowledge of the image which you are considered for the sake of line detection in the image. Okay, so that is the what we can to understand from this. Similarly, let me to take one of the figure which we can illustrate for the best example of line detection using the filters as we said in the above. A is here. This is A. What we are saying about this A is a original image. In this original image, that we are defining from B to E, detecting lines in the vertical, horizontal, 45 degrees, okay, 45 degrees direction, and negative is 45 degrees respectively. Where we can see that the values which we are defining in terms of positive, where we define in terms of what we call, positive lines and negative lines. Okay, so which we understand from each and every line detection of an image, okay, that image which we can help us towards to understand the pixel of the intensity levels in terms of your representation of line detection using filters process. So how we may understand in detail about this, we are going to have one more definition which we can define in terms of each and every line, nothing but group wise or separate wise we can approach. So that approach we can define in terms of segmentation based definition. What is that segmentation definition which we can follow? The line detection is here. We simply define region based segmentation. What we call is region based segmentation. So this region based segmentation we called as a approach consists of partitioning an image into regions that are similar according to a certain set of criteria. The region based segmentation technique involves an algorithm making segments by dividing an image into various components that have similar pixel characteristics, which we can apply the particular technique named as techniques such as for small or big chunks in an input image for segment process purposes. So that we will either and more pixel to the selected chunks or further dimension checkpoints into smaller segments and merge them with other smaller chunks, which we called as here smaller chunks points. Okay, so that we are going to be defined here in terms of the technique which can be applied. For the sake of, if at all we concentrate to define such a segmentation, which we named as region-based segmentation, that segmentation where we define or how we define from how we got in the sense, which we are already have the certain awareness about segmentation method, which is simply we classified from this figure, from this block diagram. So that means segmentation is classified into two parts based on discontinuity, based on similarity. Edge based and threshold based, region based, special threshold based. Okay, so if at all we go ahead with neural network based, then cluster based, clustering based, and wavelets based, we are going to have in detail about this segmentation method. So, for example, we going to have the example to understand such a definition based on the basic techniques which we can apply in terms of region-based segmentation, which we divided into three parts of example. One is region growing, second one is region merging, and third one is splitting. So, the basic definition which we can understand from this image, which is named as original image called as Lena image. Excuse me. So this Lena image which help us to understand how we segmentally will define in terms of separation. That is what we want to understand in detail about this segmentation. Okay. So coming to the what we want to understand about segmentation is here a color model is a specialization of 3D coordination system and a subspace within that system where each color is represented by a single point. So that means you are right now understanding the previous example, which is region based, splitting based. Okay, so such a region growing based of segmentation, how can we apply? So based on the perfect definition of what this one of the example which we consider to define about the color model. The meaning of color model is here we define simply what do you mean by color model. A color model is a specialization, is a specification of 3D coordination system and a subspace within that system where each color is represented by a single point. Therefore, in an image, a great deal of exact, that is nothing but extra information may be contained in the color. And this extra information can be called to simplify the image analysis. Okay, and the example is object identification and extraction based on color. So what is the meaning of color is here? We simply use the basic color which is nothing but RGB color. RGB color. What do you mean R? Red. G means green. B means blue. RGB color. It is a standard color model. Okay. So that we consider here in terms of 3D color model. What do you mean this? We are taking that in your what we called coordination system, that is 3D coordination system is here. If you consider X, Y and Z, you are going to be have that relationship is here red, okay, next green, next this one is blue. Okay, so based on red, green, blue, we understand towards to express as a 3D coordination system. So the meaning of color model is we define according to the your coordination system only. I hope you got very clear about this coordination system. Then we want to go in detail about to define such a color image processing here. The color image processing usually we used to define in terms of the human visual system which can distinguish hundreds of thousands of different color shades and intensities, but only around 100 shades of green. That is what we want to understand. Three independent quantities are used to describe any particular color. That is, hue is determined by the dominant wavelength. Is here visible colors occur between about the length which we consider in between 400 nanometer to 700 nanometer. So which we are 400 is minimum, which we consider is violet, and 700 is which we are consider red on the electromagnetic spectrum. So based on this spectrum, we define your hue is determined by the dominant wavelength. The dominant wavelength which we are defining from the spectrum, from the electromagnetic spectrum. That is what we want to understand, the fundamental definition about color image processing. If the spectrum changes electromagnetically, then automatically your color of the length in between 400 nanometer to or 400 nanometer and 700 nanometer will be defined. In between this will be defined your wavelength of the color image processing. How it is happen? Let me take this best example which we consider to understand about these definitions and terminology on image processing. So what are the brightness bodies? That is, brightness embodied is the achromatic notion of intensity and is a key factor in describing color sensation. How this color sensation will be happen in between that the range of 400 nanometer to 400 nanometer to 700 nanometer. You see these different colors. So at 400 nanometer, what type of color we can observe? 700 nanometer, what color we observe? That is we could written as red. This is we written as violet. Isn't right? Violet. So such a colors which we are defining in a simple manner, which we want to define the meaning of brightness bodies in a color model is brightness embodied is the achromatic notion of intensity and is a key factor in describing color sensation. That is, shorter wavelength is now changed to longer wavelength. That is, shorter is now 400 nanometer. Longer wavelength is 700 nanometer. In between these, how many colors we can change? We can change any type of combination color model, which we in terms of defining gamma rays nanometer, X-rays nanometer, ultraviolet nanometer, visible spectrum nanometer, infrared nanometer, and radio waves nanometer, which we keep in terms of certain numerical value which we are defining such a race. So you are supposed to be follow the simple definition about brightness bodies based on the different measured values of the wavelength of a electromagnetic spectrum based color sensation. So you see here what are the primary and secondary colors which we can be identified for defining the meaning of primary color and the defining the meaning of secondary color is here. Simply we say, suppose somebody may ask you what does it mean the primary colors, or how many primary colors we can use for the image processing, or what are the secondary colors which we can be defined in the image processing. So we can simply follow this definition which we named as three primary colors are red, yellow, blue. The three secondary colors are orange, green and violet. So such a colors which we consider as secondary colors. These are the secondary colors. Okay. And this one is primary colors, which when we know this is a primary colors. Okay. So if we compare in between those different types of color models which are used in the image processing and obtain the signals and system for various purposes. for various purposes, because this image processing is having a wider range of interdisciplinary applications. That's what the purpose of such a definition of the primary and secondary colors, which we are going to be used for the purpose of image processing in signals and system. So some of the common color spaces are: number 1 RGB, number 2 CMYK, and number 3 HSV, and number 4 YIQ. What are these? These are the common color spaces. Nothing but spaces is nothing but certain models, color models. What are the models we can understand? One is RGB color model, second one is CMYK model, another one is HSV model, and another which we can use YIQ color model. So these are we are understanding under the primary and secondary colors definitions. So let us have to understand the definitions which we have defined in terms of achromatic versus chromatic. What do you mean achromatic, and how it can be compared with achromatic, compared with chromatic? So achromatic, which we define in terms of achromatic light, is wide of color. Only attribute is in terms of intensity measured by gray levels. For example, black and white TV. The kind of images that we discussed so far is black and white, that is gray levels images. But whereas such a chromatic light we can also define in the same way, but it depends upon the three basic what we call the quantities are used to describe the quality of a chromatic light sources. What are the chromatic light sources are? Radiance, that total amount of energy that flows from the light sources in terms of watts. Where in the achromatic light we define in terms of 400 to 400 with 700 difference, but where in terms of chromatic light we define in terms of what we call light source in watts. So we can understand the differences, that is the distinguish in between achromatic versus chromatic, which we can be distinguished very simply based on the which we understand it from the basic concepts we defined achromatic versus chromatic. Let me go ahead to understand about this illuminance and brightness based on radiance. What do you mean radiance? Radiance is a source of what we call the light. That is source of light which we defined in terms of watts. But where this illuminance also we define amount of an energy which can be defined by the observer perceives from a light source in terms of lumens, that is simply notationally called as LM. So terminology is used here. What is the LM terminology? Is luminance. And how we define that is amount of energy an observer perceives from a light source. The best example is far infrared light has a large radiance, but an observer would hardly perceive it. So that we defined illuminance, which we can comparatively define the brightness also. What do you mean brightness? Brightness, which we discussed earlier slide, towards to define in terms of we understand achromatic sources of information. That is, brightness is nothing but similar to the achromatic notion of intensity. One of the key factors in describing color sensation. That is what we are defining, describing color sensation based on the difference between illuminance and brightness. Whereas these primary colors versus secondary colors, we externally also can understand that RGB components acting alone cannot be generate all spectrum colors, which are nothing but primary colors. It is fixed. What are the fixed colors we call as primary colors are? Number 1 red, number 2 green, number 3 blue, which are noted in terms of RGB components acting alone cannot generate all spectrum colors. But if you want to see the all spectrum colors, we are going to define understandably by the comparison with the primary colors is secondary colors. That is, magenta is nothing but R plus B, cyan is G plus B, and yellow, which is nothing but R plus G. What is this? This is CY, is nothing but CMY model. What is this CMY model? It is one of the color model. How you prepared this color model? By the help of RGB only. By RGB colors only, we are defined about this, what we call the RGB, what we call secondary color. Okay, that is the secondary color. So based on this, we going to be have the mixing the three primaries. We got lightweight. That is white light. So white light color is three primaries of the mixing only. So coming to the primary colors versus secondary colors in terms of pigments, we also say that primary colors in terms of pigments, we say magenta, cyan, yellow. By the observation, observe a primary color of light and reflect or transmit the other two is nothing but secondary colors connected in terms of transmit to the other colors RGB. So once you understand such a definition about this comparison in terms of comparison of primary with the secondary, let me see the in detail about RGB stands. That is a terminology. This is the terminology. RGB stands for red, green, blue. Red is one first letter G and B. R for red. G nothing but green. B nothing but blue. That is a terminology, which we can be defined or nothing but which we can state as what RGB model states that each color image is actually formed of three different images. What are those images? We called from the electromagnetic spectrum only we define this. Red image, blue image, black image. What do you mean this? B means black. B means another B means blue. Another R means red. So we can prepare your required colors. RGB. G means green color. So normally grayscale image can be identified and defined by only one matrix, that a color image is actually composite of three different matrices. That is what grayscale image is the black and white image. Is the black and white image. This we define it is simply one matrix. But whereas this what we call three different matrices will be attained for RGB models, RGB color. Why? Because R is one of the image, R image, that is red image. B means that is the blue image. G means that is another image. So each image, it has a separate matrices values, which that matrices contains the pixels of the intensity information. So one color image matrix is red matrix plus blue matrix plus green matrix, which we are compared as one mixed color image is RGB. How it is RGB? Take it this grand RGB matrix. This is color matrix. This is color matrix, which contains one is red image, another green image, the blue image. So here only red is appear, remaining will be black. Only green is appear, remaining will be white or blue. Sorry, white only. That is green, and blue will be looking here only that color. So what we want to understand, the basic information is here. Such a color matrix is mixing of three RGB images. So how we can mix that? That is also important question is here. That we will mix by the color combination. What does it mean? This color combination, one big question to define it. So green image is having minimum 0 to 255 pixels in that matrix. Plus R means red. Red also having another separate. When we both connected, then we will get another type of image which we want to consider YMC color model. YMC color model. Or this one we also say YCM. That Y means yellow, C means KR, M means magenta. So such a colors which we are, it is a mixing. It is a mixed colors will get this model. Why we want mixed? To form a combination color model. Combination color model. White how will get? RGB. So coming to the CMYK, just now we discussed C means K and M means magenta, Y means yellow and K is the factor which is we called as a black key. It is key, K means key. So the conversion from RGB to CMY is done using this method. Simply we call as a CMYK color model. It is widely used in the printers, which we are using in our day-to-day life for taking printouts. It stands for KR, magenta, yellow and black is nothing but key factor. It is a subtractive color model where 0 represent as the primary color and 1 represent as the lightest color. That is that latest color which we simply modify based on or simply attain based on your prepared model. For example, the model is here. In this model, your prepared point is as a color model of 2 to 1, that is RGB. So here represent black will become a 0 or zeros. So that is a respectively black and white. Black is considered 1, white is represented as a zeros. So it is a subtractive model, thus value is subtracted from 1 to a vary from the least intensity to a most intensive color model. Least intensity to most intensive color value which we can understand. So as I said here, C is becoming one image. How is this image? Is red image. This is red color image. Red color image. How much it contains values in terms of formation? 0 to 255 pixel values as a 3D image or 2D image. You can consider 3D image. Consider you have a color image, means you have 3 different arrays of red, green and blue. These are the array. These are single array, one dimensional array. Now if you wanted to convert it into CMY, here's what you have to do. Excuse me. You have to subtract by the maximum number of values -1, that is negative degree of color model. Each matrix is subtracted from its respective CMY matrix is filled with different results. That is what we want to understand the definition and terminology on image processing, which consider RGB color image color model example. So coming to the such a model, we extendedly use one of the color model which we are considered here is here one color which we consider is here is black. What do you mean black? I said that cyan, magneto and yellow all together add, then we will get the black. Suppose blue we want to get, what is this? Magneto and cyan will be mixed. What is magnet plus cyan? Magnet is again it is mixed with 2 color. Cyan is mixed with again 1 color. That is cyan is a negative of red, magnet is a negative of green, yellow is a negative of blue. What is this negative of red, negative of green is nothing but which we are understand from your here what we called as simple formula which is using here 1 minus RGB. R we can use here. R is negative. 1 minus R is equal to C. 1 minus G is nothing but G, that is green. 1 minus B is nothing but white, that is your yellow. Like that, we are going to be define each and every color model which we can form for understanding color model formation. Of course, we understood so far the definition and technologies which we are consider towards to some of the definitions in image processing very clearly. I hope you enjoyed our lecture today towards to understand the simple definitions and the terminologies. We're going to be covered the remaining topics in coming class. So up to now, we can revise these topics by the help of references which are prescribed references of textbooks available in our library, and even online also available, and we can refer for that. Thank you so much. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.